So if we look at this one here, our asymptote is at 0 and 0. So x equals 0 and y equals 0. So that means we had no what? Bless you. No translations. Bless you. So we still have to check, though, if there's a vertical stretch, correct? So what you're going to do is you're going to, on the next page, let's pull a point off before. And they bold points for a reason because they want you to use those ones. So if they bold them, they're showing you that they're on that cross section. They're not kind of close to that cross section. They're actually on it. So we could pick any of these bolded ones. I'm going to pick 2 and -2. Okay? So let's go to our notes. It was on this side. So we know we have the point 2 and -2. And we know we have x, y always when it's a point. And we know we have x equals 0 as our vertical asymptote and y equals 0 as our horizontal asymptote. So that's it. We don't have any translations. So if we just have asymptotes, we can use that other equation. So y equals a over x minus h plus k. So remember, our asymptotes are basically our h's and our k's, correct? Because that's how they move. It's like how I told you exponential moves this way, so it's your vertical translation that moves it. Logarithms move this way, so it's the horizontal translation that moves your asymptote. This one moves both. Okay, so we know y. Y is -2. We don't know a. That we have to find. That's our stretch factor, and we can't forget to find it. Remember quadratics, when you always have to find the a, you always have to find the stretch factor, that a value in front of your quadratic every single time. It's the same thing. You have to do it for all of these equations. So a. And then we have x, which is 2 minus 0 plus 0. So we have -2 equals a over 2. And then we're going to multiply by 2. A equals -4. Now, just like in the quadratic unit in grade 11, we put back in the h and the k, right? And we put back in the a, but y and x always stay y and x because that's how you get an equation. So we're technically going to have y equals -4 over x, right? Because we'd add 0, add 0. Now, does this make sense with our rules? Because this is also transformed or just the numerator over denominator, correct? So we take our NPV, x can't equal 0, that's our vertical asymptote. Our numerator is a smaller degree than our denominator, so our asymptote's y equals 0. Proven we're correct, move on. Okay? Now this form is good if you only have a horizontal and a vertical. The catch though is, if it's just a basic one like this, you're good. You got both forms. But if you fill it into this form and the answer's in the other form, you're gonna have to get a common denominator and put it together. So we'll practice those as well. Okay. But remember, you can only use this if you have a horizontal and a vertical. The moment you have a point of discontinuity, can't do this. Okay. B. B, we have a horizontal asymptote at what? At y equals 0, because it's on the x-axis. And the x-axis is the equation y equals 0. And then we have a vertical asymptote at what? X equals -3. And then we also need a coordinate. I'm going to use -2 and 1. Oh, good, I coughed right into that. Enjoy that later. I forgot I was recording. X equals -3 and 0, and then that point, correct? Then we just plug it in. So we get y equals a over x minus h plus k. 1 equals a over x plus 2, because it's going to be minus and minus 2. Oh, what am I doing? -2 plus 3. And then plus 0. It's minus 3, not 2. Then we get 1 equals a over 1 plus 0. So a just equals 1. So there's actually no stretch, right? So we get y equals 1 over x plus 3. Doesn't make sense. Our MPV would be x can't equal -3. Our asymptote is x equals -3. Okay. Our numerator is smaller or greater than the denominator, so our horizontal asymptote is y equals 0. We're good. Remember that whenever you find an equation, you guys, you can always check an equation. If ever on the diploma they give you a graph and they want the equation of that graph, you can always at least walk away. I know they might be harder to do, but you can always at least walk away knowing if you got it or you didn't. Why? Take your equation, type it into your y equals, change your window to be the exact same window as theirs, and see if they match. If they match, yay! If they don't match, try again. Okay? Or sometimes look in your calculator, you literally just put them in wrong. So the y equals, that's the worst. When you actually get the calculator, when you get the equation right and you typed it in wrong. So always check that first before you like try and viciously do it over again. Okay? And I say viciously because I've seen people, they're like, put it in and the happy face goes to an instant sad face because it doesn't match. And they're like, oh. Okay, so you're going to do C and D. Try it out. I will put it on the board. So C has a horizontal asymptote. Now, please, 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 check your scales on tests and diplomas. So a whole bunch of people will tell me 2. It's 4. Okay, you have to watch and make sure you check your scales because that'll get you. So this one here is horizontal and it's cutting through y equals 4. And then this one's cutting through x equals 2. And then I have a coordinate at, I'll use this one, -2 and 2. Seem to be consistent with my 2's here. Okay, yeah. Now remind me when I get to the next page. 4, 2. Y equals 4, x equals 2, and then -2 and 2. I think I said. X, Y. Okay. So y equals a over x minus h plus k. So we get 2 equals a over -2 minus 2 plus 4. Now, if you want, I would instantly go here and I would go h equals 2, k equals 4. Because if you don't, I always just accidentally put that in for x. Because I have x equals, why wouldn't I do it? And it's not right, it's not x, it's h. So this is my vertical asymptote and horizontal. So to stop yourself from doing that, that's what I would do. 2 equals a over -4 plus 4. So we subtract the 4. So we get -2 equals a over -4. And so a equals -8, +8. And so we have y equals 8, x plus, doing it again, x minus 2 plus 4. Now, this is great and correct, but the answer on the test, let's say, is numerator over denominator. So are we done? No. Could you, I guess if it's going to be numerator over denominator, it's probably going to be a numeric response, right? It's not going to be multiple choice. If it was multiple choice, you just plug all your little ABCDs in, match the graph, and go. It's probably not going to do that, right? It'd be too easy. And it wouldn't test if you can actually do the question. It would test if you can punch into y equals, which is not a curriculum outcome. So that's why they won't test that. Because we always think, what are we testing in this question? Are we testing whether you can type into y equals and match graph? Or are we actually testing the curriculum? And that would be matching a graph. Okay, so very easy, though, to put it into the numerator over denominator. You just need a common denominator. So we're going to multiply this one by x minus 2. So for this particular question, you'd actually be done, right? Because this question just asks if you have it in that form, you would be done. I'm just showing you what happens if on the diploma, they asked it for it to be numerator over denominator and you have it in that form, right? You have to keep going. So you'd get y equals 8 plus 4x minus 8 all over x minus 2, because now you have a common denominator. So y equals 4x over x minus 2. So this one works, and this one was a good answer as well. I just distributed here, put it over x minus 2, and then put them all over x minus 2, right? Just common denominator. So you distribute this, you get 4x minus 8 all over x minus 2. And now you have a common denominator of x minus 2, so you'd go 8 plus 4x minus 8. Collect terms, get your answer. And then you can check and see based on your rules, right? Still, x minus 2, so x equals 2 is your vertical asymptote. Now, numerator and denominator, same degree. So we take a fraction of their leading coefficients, right? 4 over 1, 4. Yay, we know we're right. Okay? D. D, we have, once again, scale of 2. So the y is a scale of 2. The x is a scale of 1. Do they have to be the same scale? No. So we have, this is cutting through y equals negative 6, so that's why it's y equals negative 6. This one's cutting through x equals 1. And we have a coordinate at 0 and negative 2. 1, negative 6. 1, negative 6, 0, negative 2. Do you have to use the same point as I used? No. As long as it's a bolded point, it should work. You should get the same A value. So we have, this would be h equals 1, k equals negative 6, x, y. So we're going to get negative 2 equals a, 0 minus 1 minus 6. Negative 2 plus 6 equals a over negative 1. I'm going to add 6 to both sides. 4 equals a over negative 1, multiplied by negative 1. A equals negative 4. So we have y equals negative 4, x minus 1 minus 6. Which is correct. However, they might ask you for numerator over denominator version, right? Full numerator or full denominator. So then you're going to have to get a common denominator. Now, this one I know compared to the last one, I'll get more errors because there's a subtraction sign in between, right? So that subtraction has to go to both of them, yeah? So you could either have distributed the negative 6 and right away and turn this to a plus sign, or you can leave the negative here and then distribute it. Mm-hmm. Oh, that's disappointing. Thanks for letting me get to the answer, guys, before correcting my x minus 1. Knew something was wrong, and that's why I was going slow, because you all had the same face. The face of, I think this is wrong, but I'm just not going to say anything and see if someone else does. If that was x plus 1, it would have been totally that answer, just so you know. It's really good. But it wasn't, so we'll try this again. The whiteboards. There. Where are they? I think they're on there. I think so. All right, x minus 1 minus 6 times x minus 1, x minus 1. Y equals negative 4 over x minus 1 minus 6x minus 6 over x minus 1. Y equals negative 4, x minus 1, minus 6x plus 6. Y equals negative 6x plus 2. Okay, so x equals 1 would be your asymptote for the vertical. And then same degree, so coefficient negative 6 and 1, so it's negative 6. You could take a 2 out, but if you take the 2 out, then you won't see the, you won't see the negative 6 as your horizontal asymptote. But if you were solving it or asking any questions about it, you could. Okay, now we're going to look at number 8. Well, I'm scared of, it went crazy last time I did that. Okay, number 8. No, you can do it on the whiteboard. So number 8, I just wanted to show you just in case you were given something like this, because you know throughout the units you've been given questions where we have to do substitution or elimination, right? It's whenever we're solving for something, we're given partial of something, we're often given 2 points, and we need to find some values, okay? Here's another one of those. So the rational function y equals a over x minus 7 plus k. So always think, if I'm stuck, maybe substitution or elimination. Who knows? Let's try it out. Because this would be xy, correct? And this would be xy. But what do I not know? A or k. Whenever I'm missing 2 variables, but I have 2 points, I can always do substitution or elimination. That has to kind of roll in the back of your head just in case if they give you something like that. Because it can pop up in any unit, right? Okay. So we're going to get 1 equals a over 10 minus 7 plus k. And then we're going to get 9 equals a over 2 minus 7 plus k. So we get 1 equals a over 3 plus k. And then I'm going to multiply them all by 3, so I get rid of the fraction issue. So I have 3 equals a plus 3k. I have one equation. Yay. I'm going to get the other. 9 equals a over negative 5 plus k. And multiply by negative 5. Negative 45 equals a minus 5k. And now you could do substitution or elimination. I'm going to choose elimination. I often do because I just find it easier. Also, I have 2 a's that are the same, so they'll eliminate. So I have a plus 3k equals 3. I like writing the variables on the left. It's just what I like to do. A minus 5k equals negative 45. In order for the a's to eliminate, I'm going to have to subtract the whole thing because they're both positive. So a minus a cancels. 3 minus a minus 5 is positive 8k. equals 3 minus a minus 45, so positive 48. So k equals 6. And then I can just take that value and plug it in to the other one. Negative 45 equals, I could have plugged it into this one too, it's easier. I just don't have a lot of room, so I'm just doing it under that one. I would actually pick this one on the test because it's way smaller. Negative 45 equals a minus 5 times 6. Negative 15 equals a, because you'd add 30. And they want the equation. They don't want just a and k, right? So if they ask for an equation, you actually have to draw it out. So y equals negative 15 over x minus 7 plus 6. And then how could you check it? How could you check it? You could put that in, you could check your points back in and see if left side equals right side. You could type it into y equals and see if those points are on the table. There's all those options, right? They gave you 2 points that are for sure on that graph. It's good. Okay. And we're going to go back to the note. So we're going to go to example 3 on page 449 in your textbook. Yeah. It doesn't work that great. I would rather, you probably could get a paper towel better. The eraser will leave it be black, but you try. Okay. So we're going to quickly look at these and then we're going to finish the last example. So match the equations of each rational function with the most appropriate graph. That doesn't mean type into your calculator and look for the one that matches it. That's a bad decision. So our best bet is to actually factor the tops and the bottoms where we can if we want to. The top and the bottom can help you in the fact that if something cancels off, then it's a point of discontinuity. If it doesn't, it's an asymptote, etc. Right? So if we look at a of x, this is in your notes. It says look at example 3 and then do the other. You're going to try the other one. So here we have x and x plus 2 over x minus 2x plus 2. So the x plus 2's cancel. So what does that tell me? I have a point of discontinuity at negative 2 and something. Because we're matching, do we have to even find that something? No. But what we could do is we can find that something. We'd have to plug it into here. So we'd get y equals negative 2 over negative 2 minus 2. You plug it into what's left over. So it's negative 2 over negative 4, which is a half. Remember, Friday is the day to bring in your, by then, to bring in your $5 thingy. So, because if you don't bring it in, I'm getting stuff on the weekend, so. Okay, graph 2 matches it, right? And then I have a vertical asymptote at x equals 2, right, because it's left over. And now I have x over x minus 2 left over, correct? So they're both the same degree, correct? So we take the leading coefficients, which is 1. So I know I have a horizontal asymptote at y equals 1. So here's my horizontal asymptote at y equals 1. Vertical asymptote at 2. Point discontinuity at -2.5. We agree? B throws people off because they think x squared plus 1 is a difference of squares. Difference of squares means there's a difference sign. There's no difference sign. It's an addition. It's an addition of squares. Okay? An addition of squares you can do nothing with. You can't factor it. You can't anything. It's x squared plus 1. It's going to get you the wonky graph, graph 3. We don't ask you to do them. It's just a point that x squared plus 1 doesn't factor. Okay? You're going to get wonky graph 3. And then the C one, you have 2x, and then you have x plus 2x minus 2. Did anything cancel? No, so I'm going to have 2 vertical asymptotes, one at x equals 2 and one at x equals -2. So it's going to be graph 1. The degree of the numerator is smaller than the degree of the denominator. So I'm going to have a horizontal asymptote at y equals 0, which I do. Now it crosses through here. People freak out. It just does that. You have to do it because the asymptote actually just covers the end behavior. It doesn't have to cover the middle. Which limits you'll see in calculus as to why that happens. Okay, we're not going to do the your turn. We're going to go to question number 8 next. It's listed on your, it's your last question in your notes. So what happens if, is it 7? Okay, 7. What happens if we don't just have asymptotes? What happens if we have points of discontinuity? How do we write the equation? So the last one we could do, because we didn't, oh, come on. We didn't have any points of discontinuity, but now we do. So it's not too bad. Before we go on and do any of these questions, actually, I'm going to look at something on the side here. So you don't need to write this down, you're just paying attention. So say I give you y equals x over x plus 2. And I ask you to find the x-intercept. What did we do yesterday? We turned this into a 0, and we brought the x plus 2 up, and what happened? It canceled. And what were we left with up here? X-intercept, x equals 0, right? Okay. What if I have y equals x minus 3 over x plus 2, and I asked you to find the x-intercept? Go here, 0 equals x minus 3 over x plus 2. I would multiply the x plus 2 left, right? We agree? And my x-intercept would be 3, right? Whatever you're left with in that numerator does tell you the degree to help you for your horizontal asymptote, but whatever you're left with in that numerator is the reverse of your x-intercept, right? So my x-intercept was 3. I have x minus 3 up here. My x-intercept was 0. Well, I just have an x. If it was 2x plus 3 over x minus 4, let's say, I can tell you that my vertical asymptote's at 4. I can tell you that my horizontal asymptote's at 2, because it's 2 over 1. And I can give you my x-intercept instantly. I would just take the numerator and set it equal to 0. Why can I do that? Because whenever I'm finding the x-intercept, I'm plugging a 0 in, your denominator's coming up and canceling off anyways, and then you're solving. So you'd have 2x equals -3, x equals -3 over 2. Okay? So technically your numerator, unless it's canceling off because it's the point of discontinuity, the piece of your numerator at the top is your x-intercept. Solved, like backwards, as the factor, not as the root. Okay? Knowing that, let's do number 7. So number 7 is here. We know points of discontinuity. We know points of discontinuity. I can't even. We know points of discontinuity cause a factor that's the same on the top and the bottom, correct? We know that there's an x-intercept on the top always, correct? We know that the bottom contains your vertical asymptote, technically backwards. It's always the factor of all the things that are solved, correct? And we still have to solve for an a. Okay, So let's do this. So we have an equation. We can't put this in the y equals a over x minus. This is whoever watches is going to be like, why is she laughing? Everything's dropping. Stuff's dropping everywhere. The sky is falling. Okay. Enjoy this. I'm coughing into it. So I'm laughing into it. It's bad. Okay. We can't use the y equals a over x minus h plus k because there's a point of discontinuity, correct? We can't use that form. Don't try and use that form. Don't try and add it to the bottoms to make that form. Don't do it. Stop the madness. Okay. When you have the point of discontinuity, you're going to y equals, you know on the top and the bottom you're going to have that x value, correct? So our x point of discontinuity is at 0, correct? If it was at 2, we'd have x minus 2 on the bottom. If it was at 5, we'd have x minus 5 on the bottom. If it was at negative 5, we'd have x plus 5 on the top and the bottom, correct? If it's at 0, what do we have on the top and the bottom? Just x. So we know we're going to have an x on both the top and the bottom. We agree? We also know on the top there's always what? We just went over it. Like I literally just showed you it. The x-intercept, the reverse, the factor of the x-intercept, correct? So where does this one cross the x-axis? At negative 6. So we're actually going to have x plus 6. On the bottom, what else do I have? Your vertical asymptote. What if there isn't a vertical asymptote? Then I wouldn't have to put a factor down there besides the one that's there, right? But there is. There's a vertical asymptote. It's at negative 2. So what am I going to put here? X plus 2. And then the one thing you have to not forget to do, find A. You always have to find A, because there could always be a vertical stretch factor. That's why in the quadratics, when you use the vertex and you use the point, you still were solving for A. Because you don't know if there's a vertical stretch factor, because the vertical stretch factor isn't going to affect the other things. So we define it using a point. Do not use, we try and not use y-intercepts and x-intercepts if we can help it. So I'm going to use this point. They usually bold more than one. So I'm going to use negative 4 and negative 1. You can do this in your notes, right? There's a section. I just don't really feel like flopping back and forth. So negative 4 and negative 1. Make sure my scales are 1s, which they are. And then I'm going to have negative 1 equals a negative 4 plus 6 times negative 4 over negative 4 plus 2 times negative 4. So negative 1 equals a, and then 2 times negative 4, which is negative 8, over negative 2 times negative 4, which is positive 8. I'm doing that right? Yep. And so negative 1 equals negative 1a, divided by negative 1, and a equals 1. So had you not found found a in this instance, you would have lucked out, because it's 1. Okay? It's not always 1. So our equation is y equals x plus 6 times x over x plus 2 times x. Do you think they're going to have it in this form? They're probably going to have it distributed back. They're probably going to have x squared plus 6x over x squared plus 2x as the answer. Okay? This is correct, though. Absolutely correct. But they'll probably just distribute it in at the end. So when you're making equations with points of discontinuity in your notes, you could write this. I'll come back to this in a second. So now this isn't the actual x-intercept. This factor comes from the x-intercept, right? This factor comes from the point of discontinuity. So they're always the opposites, right? And then you'd have, this comes from your vertical asymptote, And this comes from your point of discontinuity. Now you can think about it. If you don't have a vertical asymptote, you wouldn't fill in this blank, right? If you don't have a point of discontinuity, you wouldn't fill in these. So could you do the other ones where it was just a vertical asymptote and a horizontal asymptote and do it this way? Yeah. You would just put the vertical asymptote down here. You put the x-intercept up here and solve for a. And you don't actually have to do it as the a over x plus h plus k. That version's way easier if you're asked for transformations, though. So you could do, you could find any graph equation using this, but you can only find the graphs with with vertical asymptote and horizontal asymptote using the other way. Okay, this one works for all. The other one only works if you have no points of discontinuity. Okay. You guys try B. Now, sorry, as an aside, if the x-intercept is at 5 over 3, let's say it's not, but say the x-intercept's at 5 over 3, you would never put in x minus 5 over 3. Okay? Is it wrong? No, but they'll never have that answer there. They'll never have a weird fraction in the bottom. They'll have, bring the 3 up, 3x equals 5. It subtracts 5 over 3x minus 5. They'll have that as your x-intercept. They'll have that as your factor. They'll never have x minus 5/3. They'll never just move the fraction over, okay? They work their way back, just like we did with quadratics in grade 11. We did that too, okay? Just like we did with polynomials, right? When we found polynomial equations, if your x-intercept was at a fraction, you never wrote x minus a half. You'd write 2x minus 1 as your factor, okay? So try out B.